Welcome back to the deep dive. Today we're looking at something that is, well, it's a bit of a contradiction, really.
It really is. We're talking about legacy analog phone lines.
POTS, right, the plain old telephone service.
Exactly that. But bridging that technology straight onto modern fiber optics, we're looking at this one device in particular, the Thor broadcast F-16Tel transceiver.
So I guess our mission here is to figure out why. I mean, why would an enterprise need to carry 16 analog phone lines in this day and age?
And not just carry them, but carry them over fiber. What's the mission-critical benefit?
And, our source material gets right to it. The main hook, the thing that changes the whole equation, is a direct quote.
Oh, yeah.
It says the connection this device provides is, and I'm quoting here, secure and impossible to bug.
And look, that's not just a marketing line. That's physics.
Right, because unlike copper wire, fiber optic cables don't give off an electromagnetic signature that you can tap into.
Exactly. Passive interception is essentially, ruled out. It's just inherently secure.
That immediately puts this into a whole different category. So, okay, let's unpack the hardware a bit. The core function of this F-16Tel is pretty straightforward. It takes those 16 POTS lines.
Your standard two-wire PSTN lines.
And just converts them for fiber transmission. And the distances here are pretty wild. The base models work up to 20 kilometers.
Over single-mode fiber, yeah. And they have options that extend that to 40 or even 80 kilometers.
Yeah.
We're talking about connecting entire campuses or remote facilities.
So does that kind of extreme distance introduce any timing or latency issues, especially for legacy gear like a fax machine?
You would think it might, but surprisingly, no.
Yeah.
The signaling is robust enough, but the really critical technical detail here is the flexibility.
In what way?
It's how the POTS port itself is configured. You can set it as either FXO or FXS.
Ah, okay, I saw that. With just a simple DIP switch.
Just a little switch. And that versatility is, it's everything when you're dealing with these kinds of legacy systems.
So just to clarify for everyone, FXO would be used when you're connecting to the carrier side, like a PBX trunk line.
That's the one. And then you'd flip it to FXS when you need to power the actual end-user equipment.
Like a telephone set itself or a fax machine.
Oh, that dial-up modem, yeah.
Yeah.
The system provides all the service features you'd expect, like caller ID pass-through.
I even saw it supports selectable ringing frequencies, 20, 25, 30, 50 hertz.
All to ensure that whatever piece of analog gear is sitting at the far end is perfectly happy.
So you got security, you got distance, and you have this incredible legacy compatibility.
Which makes it crucial technology for, say, data carriers or service providers who absolutely cannot risk a physical tap on their communication lines.
The stakes are just too high, and for that kind of application, you need reliability to match.
And the specs really back that up.
Mm-hmm.
When you look at the physical interfaces, you see the familiar RJ11 phone jacks.
For the copper side.
Yeah.
And the rugged STPC optical connectors for the fiber link.
And the MTBF, the mean time between failures, is listed at 125,000 hours.
Wow. That's, what, over 14 years?
It is. So when you see the price tag, which is around $3,500...
it actually starts to look like a pretty sensible infrastructure investment for something that critical.
And it's not just a one-off product. The fact that it's part of a whole line, there's an F8Tel, an F4Tel for fewer lines, it shows this is designed for wider deployment.
So this is for a true enterprise modernization project.
It's fascinating. They've essentially taken this ancient technology and just fortified it for the 21st century.
Giving it these secure, long-distance connections where traditional copper lines are either too vulnerable or just can't compete.
Right.
So here's a final thought to leave you with. The source mentions that this transceiver, when it's operating in that FXS mode...
when it's powering a device.
Exactly. It requires a 48-volt DC battery source, a backup. So what does that tell you about the hidden infrastructure needed to keep a vital, secure analog link running flawlessly over modern fiber, especially during something like a catastrophic power outage?
Something to mull over.
Until our next deep dive.